Hello and welcome to today's video. Today we'll be looking at maths and biology. So we'll be looking at the following four tests: standard deviation, the chi-square test, Spearman's rank, and t-test. I'll go through each one individually, what they're used for, how we calculate them. Standard deviation. All that standard deviation is basically tells you how each member of the group differs from the mean of that group. So basically you have a bunch of data, a bunch of numbers, and what it will tell you is how close or far from the mean of that data that number is. It's useful to find out how big a range of data you've got. So the smaller the standard deviation, the more clumps around the mean the values are. The way you work this out is you take each individual value of a data set, you minus it from the mean, you square that, you add all of those numbers together, and you divide it by the number of value in the data set, and that gives you your standard deviation. So if we look at this example, what you do is you initially work out the mean. In this case, it's 7.3. Then you take away each number from the mean, add all of these numbers up, and divide that by, in this case, 6, as there's 6 values. That will give you a standard deviation, which will tell you how close or far away each individual value is. So that gives you an idea of how good the sample of data is. Obviously, the more numbers you have, the better your data will be, because it will be closer to the mean, because you'll have a lower standard deviation. Next, we come to the chi-square test. Now, the chi-square test is used to look at differences between two variables. So what you're doing this is basically you're saying whether there is a statistically significant difference between this variable to that variable. And what it relies on is something called a null hypothesis. The null hypothesis is written as HO, and what it basically says is there is no difference between the variables. And you have the actual hypothesis, which is there is a difference between variables. And what you're actually looking to do in this is to reject your null hypothesis and accept your actual hypothesis. And the way you do that is by using a statistical test called chi-squared. So what we do in this time is we look at the frequencies that we observe. So what did we actually see? We minus that from what we expected. You square that number and you divide it by the frequencies expected. And you add that up. And that gives you a chi-squared number, which you then use to work out whether you can reject this or not reject this. Now let's say we took a bunch of people and we asked them what their star sign was. And we wanted to see if there was a difference in any of those variables. So H0 would be there is no difference between the star signs of a random group of people. Your H1 would be there is a difference. Okay, so in this example, 256 visual artists were asked, and we'll see how to work out the chi-squared. So our first column is the actual numbers observed, so how many people had different star signs. And then we need to fill out our expected column. So for our expected column, it's basically what we're assuming is there is no difference. So you add up the number of people, 256, and divide it by how many different categories there are, 12, which equals 21.3 recurring. And that becomes the expected value, because what you're basically saying the expected is there is going to be no difference between the different zodiac signs in this case. So then what you do is you minus your observed from your expected value and square that number, and that gives you your third and fourth columns. Once you've done that, you then divide it by the expected value again, and that gives you this fifth column of component, and you add all of these numbers together to give you your final chi-squared value, which in this case is 5.09, and then we need to compare that to our chi-square table, tell us whether it's statistically significant or not. So to tell if it's statistically significant or not, we need to compare the chi-squared value we found to our degrees of freedom, to our critical value. So the degrees of freedom, you basically work out how many observations you had minus 1. So in this case, we had 12 observations minus 1, so we have 11 degrees of freedom. So if we look at the value for 11 degrees of freedom here at a 0.05 critical value, 0.01 or 0.001, basically 19.65, 24.725, 31.264. So in this case, our value of 5.09 is lower than the critical values at 0.05, 0.01, and 0.001 probability. Therefore, we cannot reject a null hypothesis. Therefore, we would accept a null hypothesis, which means there is no statistical difference between a random group of people and what their star sign is. So that's what the chi-square test is used for. It's used to tell you if there is a difference between variables. Next, we come to Spearman's rank. So Spearman's rank is basically a technique which will summarize the strength and direction of a relationship between two variables. So it's how strong is that relationship, and whether that relationship is negative or is it positive. And what it will result is basically a number between 1 and minus 1. And this will tell you how strong the correlation is between your data. So what you do initially is you state your null hypothesis, which is the same as when we did the chi-squared, where you do H0 is there is no difference and there is a relationship. H1 is there is a relationship whether it's positive or negative. Then you rank the data. You calculate the correlation coefficient using this formula, where n is the number of paired items and d is the difference between each pair of ranked measures. You compare your RS value, your Spearman's rank value, to your critical value data table, and then you can write your conclusion referring to your null hypothesis, whether that's positive, whether it's negative, etc. We can accept it, we can reject it. So let's say we wanted to work out if a test was harder than another test. So what the relationship is between that. So initially we'd have our HO, a null hypothesis, as the same with the chi-square test, where we'd say there is no difference between the two tests, and H1 is test 2 is harder than test 1, for example. So what we do first is we work out the rank of the values of the test, so test 1, test 2. So in this case here, you see test 1 ranks quite nice and easily from 7 to 1. Test 2, however, you have two values where the numbers are the same. So the way you rank that is you basically put them in order, and wherever they'd fit, you rather than going 2 and 3, you go 2.5 for both of them. And then you minus the rank differences. So test 1, for example, for the first value is 7 and 7, so it's 0. The way you know you've done this correctly is if you add all of this column up, it should equal 0. If it doesn't equal 0, you've done something wrong. Okay? And all you do is you square that value to get your d squared, and then you add it all up to get your sum of d squared, which is this part here. So to work out our final Spearman's rank coefficient, what we do is we times that value that we've worked out as sum of d squared by 6. We divide that by the number of values there are, so 7, cubed minus 7, and then minus that whole thing from 1. And that will give you a number which you then compare to our critical value table. Then we compare the number we just worked out for our Spearman's rank coefficient. We look to see where it fits. So we had 7 individuals in a sample, so we look at number 7. And if the value for our coefficient was greater than that, we could reject the null hypothesis, same as in chi-square test. And if the value was less than that, we'd have to accept the null hypothesis, or not accept, but not to be able to reject the null hypothesis of of it being statistically significant difference between both sets of values, both variables. So that brings us to the last statistical analysis, and that's the t-test. Now, t-test basically tells you there's a significant difference between the standard deviation and the mean of a set of data, and there's two types. There's paired and there's unpaired. So paired we use if both sets of data came from the same individual. Unpaired we use if it's different individuals. So to work out your value for your paired t-test, all you do is you do the sample mean of the differences divided by standard deviation of differences, and divide that standard deviation by the square root of the sample size. And for that, degrees of freedom is again n-1. For unpaired t-tests, what you do is you need to work out this t equals mx minus my, which is the mean of your x value and your y values, and then you divide that by your s x squared and sy squared, which is divided by your nx and your ny. So to work out your s squared, basically you do the sum of your x, which is your individual scores, minus the mean squared, divided by n minus 1, which is the number of scores in the group. You do that for group 1 and group 2, and you assign one of them x, one of them y. So by doing this, you work out t-score. Now, t-score tells you the difference between groups and within a group. So large t-score means a massive group difference. And small obviously means small difference. What I encourage you to do at this point is to look through the tutorial you would have done with Miss Dillon regarding t-tests, and to see how to use the paired and unpaired and how to work out an example. But what we need to think about is, where do we use it? So if we think about whether we're using paired or unpaired t-tests, basically if we're looking for a relationship between groups, we use paired t-tests. If we're assuming there's equal variance between groups, we use an unpaired t-test. That's how we decide whether to use a paired t-test or an unpaired t-test. So lastly, we need to decide what type of test to use for what. The ones we've concerned ourselves with are the Spearman's rank, t-tests, chi-square test. Okay, don't worry so much about Pearson's correlation coefficient right now, and standard error and 95% confidence levels. That's just looking at standard deviation, basically. Okay, so we looked at that a little bit as well. So all you basically do is you decide if it's measurements or is it frequencies. If it's frequencies, so it's an investigation involving the number of individuals in particular categories, you use a chi-square test. If it's measurements which are taking actual measurements, then what we look for is, if we're looking for associations between different measurements, use a Spearman rank. If we're looking for differences between measurements from different samples, we use either a paired t-test or an unpaired t-test, or a standard deviation test. And if we're looking for association between measurements, we use Pearson's correlation coefficient, but don't worry about that yet. I hope this video has helped a little bit. If you would like me to send you any of the stuff on the t-tests from the tutorials you may have missed, please let me know. I hope this helps. Thank you.